physics and astronomy, and it's used for other general purposes, but those are the main departments. And this is part of the whole science center. We've got chemistry and biology and engineering here. So you've all seen lightning. You've all heard thunder. And lightning is just electricity. If you set up a charge somewhere, electricity is going to flow. What happens in a thunderstorm is you build up a lot of charge at the bottom of the clouds, and it has nowhere to go until eventually it builds up so much that it makes an arc and connects to the ground and get a bolt of lightning. And one effect of that is it releases that charge. One effect of that you're more familiar with is it makes a huge flash of light. But the effect that you're probably not as familiar with is it also generates an insane amount of heat. The temperature right along a lightning bolt is comparable to the temperature of the sun. And that heats up all the air around it. And when air gets very, very hot, it expands. So all the air basically gets blown away from the area of the lightning. A moment later, the lightning bolt is done. And when I say a moment, I mean a tiny fraction of a second later. Lightning bolt's gone, the air cools down again, and you've got a vacuum, partial vacuum left behind where the air got blown out. Nature abhors a vacuum. The air around it rushes back in to fill it. That's thunder. Thunder is not the sound made by electricity. If you run electricity in a circuit, you don't hear any sound at all like thunder. The sound you hear is the sound of air rushing back in to fill the vacuum made by that intense heat. That's what we're going to demonstrate for you now. Only there are certain practical difficulties involved with recreating the temperature of the sun in the courtyard in front of McConnell. I don't advise you try it. So we're going to go the other way. Instead of generating that high a temperature, we're going to start with an incredibly low temperature and then quickly heat it up to something more normal. So the way we're going to get a really low temperature is we're going to use what's called liquid nitrogen. It's not just called liquid nitrogen, it is liquid nitrogen. It's nitrogen, basically air, that's been cooled so much it becomes a liquid. It's at 90 degrees above absolute zero, or almost 200 degrees below 0 centigrade. And I'm going to pour a bunch of it in that cooler, and then we're going to take 2 kettles of boiling hot water, thank you, and I'm going to dump it in the liquid nitrogen. It will have much the same effect as what I said about lightning. That will suddenly go from 200 degrees below to about 100 degrees above 0 Celsius, and it will expand incredibly rapidly. All the air will get blown away, and then an instant later, the air around it will rush back in, making a sound of thunder. I feel compelled to say, after giving that intro, that sadly what you're going to hear is not what you've heard if you were ever this close to a lightning strike, which I hope you weren't. It's the same effect, but picture a lightning bolt going from here to the cloud, making a partial vacuum. We're doing that same thing in something the size of this cooler. It's going to be a little bit less dramatic. But you should be able to recognize that it is in fact the same noise. And it's going to be dramatic enough that I would suggest you don't stand any closer than any of you are right now. Is the water ready?
Yeah, I think so. If you want to use the gloves, don't forget, because right back.
Need a hand?
That's okay.
So,
Yeah, so you don't get splashed with the liquid
begin with the liquid nitrogen. Nope. The stuff that I spilled, this is air. The only difference between that and the air around us is that's colder. So the stuff that I spill instantly just evaporates and it becomes normal gaseous air. And what's the kettles get here. Top that up a bit. Hard to tell. Minor technical difficulties. I'll wait till I see her coming and then pour a little more in.
Here we go. She's coming now.
Okay.
She's coming.
Thank you. And the other end. Oh! That was so awesome.
Dr.
Somebody was asking about what happens when you spill some. That's what happened. Instantly gone.
The tennis ball? Got some for the tennis ball?
You have a
That gives me ping pong.
Oh, do we have one that works?
Yes, it was in the bottom of the court.
Oh, great. All right, go for it.
One last mystery. You have to explain why the ping pong ball does what it does. It's too much ice on it.
Yeah, it's getting harder and harder. I like the idea of trying to do all this with a long, tall doer. Won't
that's
evaporate
what-
off as quickly.
Yeah, exactly. Okay, so it works. Why is it doing that?
Sit in front of me.